I'm going to show you the outcomes of my time drilling 3D prints. This is not going to be a complete test video using different drill bits, filaments, and infills, as this has already been done by one guy called My Tech Fun. I will link to his video in the description and hopefully have an iCard up above, but if for some reason you do want to see me do this extended testing, let me know in the comments. There aren't many reasons you'd want to drill a 3D print. Usually you can just print any of the holes or cavities you need, so why did I? Well, my reasoning is simply for prototyping purposes. I 3D printed 1:1 3D models of Hammond's 1590 N1, otherwise known as 125B enclosures, so that I could test the drill positions of a drill template that I designed for a guitar pedal that I'm developing in effort to start a small business. And of course, make sure that the drilling positions are in the right positions. The metal enclosures are a little expensive and kind of annoying to get sometimes, so 3D printing the enclosures is a preferable option for testing purposes. So the template goes on top of the enclosure, metal or 3D printed plastic. You use a center punch to punch in the holes of the template, then you drill the positions of the indents accordingly. I have only used PLA plastics in my testing, having the white and black prints be Polymaker Polylite PLA, except for maybe this other green print, which may be Hatchbox PETG, but it's probably Bamboo Labs PLA. All parts were 100% infill to my knowledge, unless stated otherwise. Additionally, I have only used a stepped drill bit for the drilling, however there were a couple of different tools used with it in our examples here. So this is our first example. This one was drilled using a hand drill with the step bit in it. As you can see, I actually got my first hole to come out decently, then on the second one I had some plastic blowout. Then on the rest of the holes, they all worked fine. There were no pilot holes and were all started and completely created and drilled with the step drill bit. Going back to the blowout, the characteristics were very predictable. The plastic split along the layer lines, and even a chunk came out between the layer line cracks. Overall, it is interesting to see how solid the print still is, even around the blowout area. Now, the problem here wasn't necessarily that it was 3D printed, but rather it was the amount of pressure I put on the drill after the hole had probably gotten started. At least this is what I think. I'm not for sure about when the pressure was wrong, as I did do this a little while ago. But I do know that the pressure applied was the issue here, though I'm sure that being 3D printed didn't help in this scenario. Anyway, as you can obviously see, I quickly found the sweet spot for how to drill the print by hand without having it blow up on me. Looking at the holes is actually pretty interesting. I don't know if it would have the same properties if you were to have pilot holes, but since the bit was getting heated up from starting and continuing to size up the hole, being a stepper bit and all that, it started to heat up and somewhat push the plastic around due to the friction, thusly creating a solid thin wall around the holes. So if the hole is made properly, there is less fear of having the layers split afterwards, though the possibility is still more likely in these pieces if the part is dropped or has a fastener get over tightened on it or something like that. Now, like I said, this is interesting, and I only used a stepper drill bit, so I don't know if creating pilot holes or using normal straight drill bits would take away some of the friction and thus the heat that makes this welcomed side effect more possible. So these next parts were drilled a while after the first because we were pouring a bunch of concrete. The reason this is relevant is because we needed an electric portable mixer for the concrete, since we were doing it ourselves and pouring a large area. I can see how you might still think this is irrelevant, but stick with me here. We borrowed one from my grandpa, but it didn't work, so we went and bought one from Harbor Freight, but it had a bent body frame, so we took it back and got it exchanged. So we looked at the frame of the new unit at the store, but the way they had packed it made it hard to inspect the mixer and also be able to repack it back in the box. So it looked fine from what we could tell. Then we took it home, and the frame was bent improperly the same exact way. We called Harbor Freight because we were also having card trouble at the time, and they said that was the last one in stock for any of the nearby locations. So because of that, eventually we returned the second bent mixer, and we asked if we could get a consolation discount on one of their more affordable drill presses. And we did. So from then on, I was using the same stepper drill bit, but in the drill press this time. Told you it was going to be relevant. The next pieces I don't have an order for because it's largely irrelevant. I'll talk about this black enclosure piece since it's mainly just conveying info we already know. This piece turned out largely perfect, just rough on the holes, which could probably be taken care of with a deburring tool. This next piece I think was done before I had printed the last shown black enclosure. This is a template that I made that didn't have the right sized holes for the center punch, so it was scrap either way now. But also because of its intended purpose, it didn't have 100% infill. I'm not sure what infill it did have, but I think maybe around 25 to 35% just to give it a little more strength and sturdiness while using it, of course. Either way, the drilled holes did come out fairly cleanly. I don't know if hand drilling in this situation would be any more complicated due to the possibility of the bit being able to be shifted in the infill geometry, but because the bit was forced in on a consistent axis due to the nature of the drill press, that factor was completely negated, if it would have changed anything at all. However, the holes are indeed less solid because the walls were thick enough that they have the infill gaps. So the plastic did not create enough of a ring to cover up the entirety of the gaps. This would mean that depending on the infill's density, the walls could flex more than expected under compression from fasteners and other things like that. Additionally, there is the possibility that this will lower the overall strength of your part one way or another. The layer lines still do seem to be somewhat welded together on the side drilling due to the heat, of course, again. So the hole's layer lines should be a little less likely to separate, even if it is still a possibility. On the other hand, separation may be more likely on this piece than others because the infill may be more likely to separate if I were to guess, which the connected infill may pull or put other slight strains on the parts of the outer plastic walls and encourage the outer layers to separate as well. So for the most part, 100% infill is of course recommended, but may not be necessary, also depending on your outer wall thickness in general. If you have thicker outer walls, you probably will have more strength in general. Our final example is this one, showing the practical application of what I was working toward. I drilled this one with the step bit in the drill press, and I think I used a deburring tool on this one because we had just gotten one. And I think this prototype came out pretty clean externally. Internally, it's a bit of a mess due to not understanding which poles to solder to on the instrument jacks. Now, I really should have used a PCB instead of real wires, but the example is here and the circuit works, and PCBs are just not good. They're getting harder to get, especially with, America. I live in America, the great president and all that. My original intention was to test everything in the plastic enclosure and then move it into a real metal enclosure. However, I didn't take into consideration the wires and such. It's a new move, but I'm not too concerned other than not really being able to close the enclosure. If you have any suggestions on ways to do that, I would love to hear them. I'd prefer a solution that is repeatable. Since this is a 3D model provided directly from the manufacturer, I should have made some adjustments to the screw holes so that there may have been a chance to put some threaded inserts in there, but the way it is currently, there just isn't a chance. At least I'm pretty sure it would just melt down the very thin outer edge of the post. The only other thing I can think of now is tape, but it's not the greatest long-term solution, especially for removing and reapplying the backplate. This is a sneak peek at a simple guitar pedal product that I have been working on for a long time. Not necessarily the circuit, but other things around it. So I would appreciate if you wouldn't try and figure it out and build it yourself quite yet, if that's your sort of thing. So back to the main topic, I have shown you my purposes and short journey for drilling 3D prints. I also saw recently a post on, I think, the 3D printing subreddit, a guy who 3D prints parts then does some CNC routing on them. I don't know if he does this for some other strength reason or structural reason, because I think that it was a basic up, down, left, right CNC routing machine, 4-axis CNC, maybe 5, I can't remember. So logically he could have just printed all the routing that he did, but I don't know. He probably had his reasons as well. Tell us what you would like to drill in your 3D prints, and tell us how it went if you actually have done some drilling yourself. Like I said, this obviously wasn't an extensive piece of research into the subject. If you would like to see more of that, there's this one guy I've seen do it called My Tech Fun, and I will try to link his video below in the description and have already hopefully had an iCard above, but I don't think you can show the same iCard twice in one video, so go and check it out. Additionally, if you want to see me do some more extensive testing for some reason, let me know, and I will see what I can do about that. For now, I hope you enjoyed the video, and if you did, please leave a like. Consider subscribing, because I do 3D printing, music, and sometimes whatever I like, and try to combine them all when possible. So again, please consider subscribing. Check out the links in the description for ways to help me out. I have linked my Maker World page and have some affiliate links to good 3D printing stuff, which I use the majority of them. Maybe just not the glue sticks, as I prefer the hairspray, which I also have linked down there. So that's all I have to say for now, so I'm gonna say bye-bye.